Okay, today I would like to review the law of sines, and I could just give you the formula and tell you how to use it, but just I don't always appreciate this when the proof is easy to do and at your level, meaning algebra 2 and pre-calculus level. I always like to do the proofs, like derive the formula. Where does it come from? So this is what we're going to do in the first slide. And the second slide, I will give you an example. Okay. The law of sine, first of all, the thing you have to remember, the law of sine is used when you have a non-right triangle. Okay. Because if you have a right triangle and you're trying to find some missing sides or missing angles, you are going to use the Pythagorean theorem, okay? Or the trigonometric ratios, which will come to, that's another video. But this is a non-right triangle. And I want to say non-right because it could be either scaling on isosceles or even equilateral, but as long as it doesn't have a right angle. So as you can see, this triangle could almost look like it has a 90-degree angle here at the top, but let's just say it doesn't have it. Let's say that this is just a random, like I said, it's not marked, so we don't know. Okay, so as we learned in our video about basic trig ratios, we've learned about our sine, cosine, and tangent sine, right? So let's say I have angle sine of angle A will always be my opposite side over my hypotenuse, right? Remember that the hypotenuse is the longest side in a right angled triangle, okay? Or you can also say it's the opposite side of the right angle, always. Okay, so remember that. And remember that our sine, I'm just gonna take that off because we need that space to work. Our sine is, I'm gonna go really fast on that because you have to have watched the other tutorials about your trig ratios. But the one we'll need today is the sines, right? So then just remember the sine is opposite over hypotenuse. You have your cosine of angle A is your adjacent side over your hypotenuse. And your tan is of angle A is going to be your opposite over your adjacent side, okay? So these are the three very basic trigonometric function, but these three work with right angles. Okay, we don't have a right angle here, but I just created one. Careful, the original triangle, the black one, does not have a right triangle. A right angle. Like I said, we don't know. This could be 91 or it could be 89. We have no idea. Okay, so we can't assume that. So let's just remember those and we'll put them aside. I will erase those and I'll be back in a second. I'll pause and I'll be back because otherwise it'll take longer. Okay, so now that my screen has been cleaned off, I'm going to rewrite the sine, right? The trig ratio sine, which is opposite over hypotenuse. So we have it here. Okay. So in order to prove the law of sines, to prove it, this is not the way we're going to use it. Remember, it's just to prove where it comes from. We're going to make a right triangle from one of the vertex to the opposite side. Okay. One of the vertex. So this is just called it's just a perpendicular segment to the opposite side of B. Okay. So or in other words, we'll just drop the altitude. Okay, remember the altitude is a perpendicular line from a vertex to the opposite side at a 90-degree angle. Okay, so this is the height of that triangle, hence that little square there. Okay, so if we created that triangle and we use what we know, right, about our law of sine, we can say that our sine of angle A, and notice that, remember that from geometry, your sides are always labeled with lowercase, and the opposite angle or the opposite side will be with the same letter but the capital letter. Okay, so that's it. That's how we match our angles with our opposite sides. Okay, just remember that. Okay, so my sine of A will equal H over C, right? My opposite side, which H, and then my hypotenuse of that triangle here that I just created, right triangle here, will be C. Okay, then we have also, let's use our angle C, but we could have done it with angle B, but in this case, I created my two right triangle using angle C and angle A. Okay, but this works also if you're doing it from angle B, but would have to do the altitude from a different vertex. Then we have our sine of C equals our H over side A. So we created two proportions here. When you are doing a proof, it is super, 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 super important to look for two values or two letters or two characters or two unknowns that are equal to each other. So look at my two H's here. Wait a minute. I have in my same image, I have two of the same letter in both of those expressions. So what I'm going to try to do here, I'm going to try to isolate that H for both of the expressions. So if I want to isolate my H here, I'm just going to multiply by C on both sides, right? So it becomes sine of A times C equals H. I didn't change anything. I just changed my my relationship here to put H alone. And I'm going to do the same here on this side times A here. So I end up with sine of C times A equals H. So now, as you notice in mathematics, it's always amazing when you get to a proof and you have two different expressions in terms of the same letter. Look, my H here is the same for both. It's the same H on that diagram. Therefore, if sine of A times C equals H and sine of C times A equals H, I could also conclude that my sine of A times C is equal to my sine of C equals A. And we talked about that in our unit about the substitution method when you are trying to solve two equations into one. Okay, so this proportion right now does not, this equation right now does not really help us to get anywhere. But check this out. What we're going to do is we're going to reorganize our expression. So I'm just going to put that a little smaller. Okay, we're going to reorganize that expression so it makes a little bit more sense and we can actually use it later on. What if, let's try to place all my A's together and my C's together. What if I take this expression here and I divide this by C on this side and multiply here by, divide by C, sorry, I just divided by C. Let me just take this out. I just did something wrong. So if I divide by C on this side, I do have to divide by C on that side as well. So you see, I just divided by C. So I'm left with sine of A equals sine, look at this, I'm going to do this, sine of C over C times A here. Can I potentially just do the same thing on that side? Of course. Let's divide that side by A. And let's divide this side. Whoops, I did something weird here. I just realized. Yeah. And let me go back. Sine, right? It's sine of A here. Okay. And let's divide by A on that side. So look what I just created. I created a really wonderful, super useful proportion. A sine of A over A equals sine of C over C. And remember what I told you before, if you do it with side B, let's say you would have done that with with C and B, it would have come up with the same solution. So we could also say that sine of B over B equals everything. So we just derived our law of sines, which is here. Okay, this is our law of sines. Sine of A over A equals sine of B, C over C, time equals sine of B over B. Now, when you solve proportions, you don't need all of those values to be able to solve. You just need portions of it. So on my next slide, I will get into an example on how to use the law of sine, okay? I'm going to pause and I'm going to prepare the next slide and you'll see me in a second. Okay, I'm not sure where I was, but I had to backtrack and redo this, so the sound might sound weird. Okay, so now, so the one thing you have to look at, if you're going to use the law of sine when you have as soon as you see a non-right angle triangle that has an angle and a side opposite given to you, okay? It could be sine B and it could be angle B and side B, angle C and side C, angle A and side A. Doesn't matter. You need to have an angle, the measurement of an angle in the opposite side. If you don't, it means you are given a SAS problem, and it's going to be a different rule that we're going to use a law of cosines for this one. So in this case, if you want to use a law of sine, you have to have a side and its opposite angle, an angle and opposite side or vice versa, okay? In this case, we do. And remember, in order to solve a proportion, we need to have only 3 values, but they need to be, 2 of them need to be aligned, and we just need another one, sine B or sine C or C. It doesn't matter which we have. In this case, what we have is the length of side C, okay? So let's set up. We know that sine A over A equals sine C over C. You see B, we have nothing, over C. We have nothing given in B, so we're just going to leave it alone. We don't need it for the moment. Let's say I'm asking you to find the value of angle C. This is my question to you. Find value of angle C, given those values here. Great. Let's start plugging in. So we know that sine of, make sure your calculator is in degrees, always. Sine of 55 over length 13, right? Equals sine of C, we don't know it. This is going to be our unknown over the side length of C. So now what you're going to do, you're going to use your calculator and you're going to literally use your proportions here. You're going to multiply your 10 here by sine 55. So 10 times sine 55. I like to click enter. Otherwise, if you forget to close the parentheses, it doesn't work. And we're going to divide it by 13. Divide by 13. Now the problem is, divide by 13. We get sine of C equals 0 approximately, right? 0. Just leave it in your calculator. Don't touch it. 1, 1, blah, blah, blah. Okay. This cannot be the measurement of the angle, right? So remember, this is the sine of C. Now you want to go back to the answer. Remember the video, the lesson that we did about inverse. You need to go back to your angle. So you're going to leave that value in your calculator and you're going to do second function sine, right? And you're going to go and get your answer, second function, answer, and enter. So the value of that angle is approximately 39. When we're going to talk about angles, so we're going to talk about the angle measures angle C, right? Equals 39 degrees. We're going to round to the whole degree, so 39 degrees, okay? So from there's a lot of things you could do. Now that you have this angle here and we have this angle here, could we potentially find this one, right? Remember the sum of the 3 angle in the triangle equals 180 degrees. So you're just going to add 55 plus 39 and you're going to subtract 180. You're going to subtract that from 180. So we are going to get a value of 86. This angle here is 86 degrees. So really, if you really wanted to solve this entire triangle, you'd have one more option. You're missing right now. You're missing right now the length of B, right? Because now we have angle B as 86, angle A, angle C as 39. We have side C. You take those because now I just side C that's 10, side A that's 13, right? So you can use any of the ratios that you're given, but let's just use this one again. We can go sine 55. We already have this one. over 13. But now let's use our angle B. We found our angle B being angle sine of 86 over B. Now we're going to do the same operation. We're going to solve our proportion the way you've learned in Algebra 1. 13 times side, 13 times sine of 86. And we're going to divide that by sine of 55. In this case, you don't have to find an inverse because you're given the side B, right? Side B right away, which is about 15, and just keep one decimal, 15.8 centimeters. Okay, and it kind of has to be a decimal. It's fine. Okay, so the angles, we're gonna round it to the nearest angle and degree. Usually this is what I do. And the side length, I'll keep 1 or 2 decimals. To me, it's enough. Okay. So that was my example. If they ever ask you, this question will be, everything we did right now will be saying solve this triangle. And often solving this triangle would also involve finding the area, but this is going to be a different video on how you find the area of a scaling triangle like this, or a triangle, a non-right angle triangle, if you're not given the height, right? So this is going to be another video. Okay, so I hope this helps.